Alright, grade 11s, today we're going to take a look at angle properties in triangles. So when we do these lessons that are rooted in the textbook, you know that there's some investigation parts. So this lesson should be paused in probably a couple places. I'll let you know when, to give you time to actually work through it. Okay? So we'll start off with this right here. On a rectangular piece of paper, draw lines from two vertices. So pick two of the corners. So it could be like these corners, this corner here and this corner here. Draw lines from those corners to a point on the opposite side. Cut along the lines to create two right triangles and an acute triangle. So this will be your right triangle number 1, this will be right triangle number 2, and this will be your acute. What do you notice about the three triangles? Can you use angle relationships to show that the sum of the measures of the angles in any acute triangle formed this way is 180 degrees? So, someone please pause this video and wait the next, well, not wait, but I'm going to wait here, not really, but wait for about 5 or 7 minutes before resuming the video, hopefully giving you enough time to work through this. Feel free to give a little bit less or a little bit more, depending on how things go. Okay, so if we take a look at the answer here, the two right triangles can be arranged to fit exactly on top of the acute triangle. This means that the angles in the larger triangle and the composite triangle are equal, so the sums of the measures of the corresponding angles are also equal. So in other words, this angle 1 and angle 3 combine to give us angle 5, right? And angle 2 is equal to angle 6, and angle 4 is equal to angle 7. Okay? So what we know is that angle 5 plus 6 plus 7 is equal to 1 plus 3 plus 2 plus 4. So if we look at that, then we know that 1 plus 3 is equal to 5. So 5 plus 6 plus 7 is equal to 5 plus 2 plus 4 by substitution. And then we, instead of 5 plus, then we know that 5 plus 2 plus 4, 5 plus 2 plus 4 all form a straight line, so they add up to 180. But we already said that 2 was equal to 6, so now we're going to put a 6 here. 4 was equal to 7, now we're going to put a 7 here. And we see that 5 plus 6 plus 7 is 180. So now that shows for sure that the angles in the triangle add up to 180. So it's a nice little proof that the sum of the measures of the angles in the acute triangle are always 180 degrees. One of those things that we kind of take for granted. Okay? Alright. I'm not gonna I think we'll try, well, we're going to try this one, we're going to try the next one. We'll try this one. So, what I want you to do here is draw an acute triangle, RED, construct a parallel line, PQ, through vertex D. Okay, so you want to make sure that this line here is parallel to this line here. Okay? Now, identify equal pairs of angles in your diagram. Explain how you know that the angles in each pair are equal. And then, what's the sum of angle PDR, RDE, and QDE? Explain how you know. So, we'll start off with identifying pairs of equal angles in the triangle. By Z pattern, we know, if we make a Z here, we know that this angle here is going to be the same as this angle here. So we know that angle PDR is going to equal angle DRE. Likewise, I can make another Z here, and angle QDE is going to equal angle RED. Okay? So that's what we know for sure. By alternate interior angles, or as I say, Z pattern. What's the sum of PDR? So I'm going to clear this off here. What's the sum of PDR, RDE, and QDE? Well, because it's through a straight line, we can say that the sum of those angles is 180 degrees because it goes through a straight line. Okay? Now, with that said, explain why DRE, that's this angle, RDE, that angle, and RED, that angle, why they're equal to 180. Well, here's why they're equal to 180. Angle RDE, or DRE, same difference. Actually, no, it's not. Never mind. DRE, or RDE, plus DRE, plus RED. Why is that equal to 180? Well, because we know that this is equal to, now we already said that, DRE, that's this angle here, is going to equal this angle here, which is PDR. So now it's going to be angle PDR. Actually, just hold on a wee second here. RDE is RDE. Then DRE, that's this guy here, is PDR. So angle PDR. Angle RED is this right in here, and that's equal to this angle here, so that's angle QDE. And that's by the alternate angle theorem. So by the alternate angle theorem, we made two substitutions. This is equal to this, and this is equal to this. So if we wanted to say that, we can say by substitution. Okay? Now that we've shown that by substitution, then what we're going to do next is we already know that these three, in part C, we showed that these three things were equal to 180. So we said that this was equal to this, and then this is equal to 180. So therefore, angle RDE plus angle DRE plus angle RED are all equal to 180. So we use that substitution using the alternate interior angle theorem and the fact that we already established that those three angles added up to 180 because they're across a straight line. Okay? In part A, it doesn't matter which vertex you draw the parallel line through. In other words, did I have to draw the line passing through D? Could I have done it through R? Could I have done it through E? Absolutely, I could have. So repeat parts A to E, first for an obtuse triangle, then for a right triangle. Are your results the same as they were for an acute triangle? So I am going to give you about 5 minutes here. Now let's say, 5 minutes here. I want some of you to try an obtuse triangle, some of you to try a right triangle, see if you can repeat steps A to E, and see if it still works. Okay? So pause this video for about 5 minutes or so. And we're back. So now, of course it still works, right? Of course, absolutely, of course it still works. It works for any triangle at all. Okay? Great. Part G, why is Dyko's approach not considered to be a proof? Well, let's see what Dyko did. Dyko just looked at it for this picture here. So why is Dyko's approach not considered to be a proof? Because she did it once. She did it once, and she might not have measured things properly. Are our results sufficient to prove that the sum of the measures of the angles in any triangle is 180? Explain. Yes, because we looked at all types of triangles before we made that conjecture. We looked at a regular acute triangle, we looked at a right triangle, we looked at an obtuse triangle, and they all worked well. So example, we got a triangle here. Find the measures of the unknown angles in MAT. So in other words, we want to find this angle, this angle. So here's what we need to know. We need to know that when we have a straight line, the sum of the angles is 180. So therefore, what that tells me is that angle ATM plus 155 degrees will equal 180. So I'm saying that this plus this is equal to 180. So angle ATM is going to equal 25 degrees. Right? Okay? Now, and you see they get the exact same thing here. So these angles are supplementary since they form a straight line. And then we can say that all the angles in the triangle add up to 180. So we can plug in the 40 and the 25 degree angle, and we get 115 degrees for angle MAT, because we've shown that the sum of the angles in a triangle is 180 degrees. So those are the measures of the unknown angles in the triangle. Okay? So, the exact same picture. If you're given one interior angle and one exterior angle, can you always determine the other interior angles of the triangle? Explain using diagrams. So, give you about 3 minutes to think about this, so please pause the video and then resume it. Okay, so if we take a look at this here, got a picture down here. If we have triangle ABC, we see that the exterior angle is equal to the sum of the measures of the non-adjacent interior angles. So, what does that mean? It means that if I draw a picture and I draw a triangle, so I draw this, and I'm going to call this X, and I'm going to call this A, B, C. It means that angle X is going to always equal A plus B. Okay? A plus B. It's not equal, it has nothing to do with the angle that's closest to, but it's equal to the sum of the other two angles in the triangle. Okay? Okay. Determine the relationship between an exterior angle of a triangle and its non-adjacent interior angles. Well, we just did that. We just did that. That the exterior angle is equal to the sum of the non-adjacent interior angles. Good. So now, here's an example. Prove that angle E is equal to angle A plus B. So we've got a picture here and wants us to show it. So why don't we watch this video that will enlighten us on why that's the case.
I needed to prove that angle E is equal to angle A plus angle B. Angle E and angle C are supplementary angles, so the sum of their measures is 180 degrees. The sum of the measures of the interior angles of any triangle is 180 degrees. Angle A plus angle B is equal to 180 degrees minus angle C. Angle E is also equal to 180 degrees minus angle C. Therefore, angle A plus angle B is equal to angle E.
Pause for the cause here. We see this word, transitive property. What does that mean? Transitive property. Well, transitive means that, let's say that x is equal to y and x is equal to z. X is equal to y and x is equal to z. If that's true, then together those statements tell us that y is equal to z. You know, that's like saying Bobby is as old as Aaron and Aaron is as old as Joe. Well, if Bobby's as old as Aaron and Aaron is as old as Joe, well then Bobby is the same age as Joe as well. Okay? Okay. Another example here. Determine the measures of these angles. So here we go. So we've got some angles given to us and it asks us to find the rest of them. So we're going to use alternate interior angles here. Okay? So we'll go through the solution here. It tells us that MN is a transversal. So for that reason, we know that this angle here is going to be the same as this angle here. So if we know that this angle here is 67, then that's got to be 47 in order to make that true. So angle MNO is 47 degrees. Done. Okay? Okay. Then we know that looking in the triangle, we can find that NMO, right, NMO is going to be 180 minus the sum of the two angles in a triangle. So that's going to be 86. It's going to be 94 degrees. Oopsies. This is going to be 94 degrees using the sum of the angles in a triangle. So NMO is done. Now we have to find QMO. Now QMO, we're going to use the fact that angles across a straight line add up to 180. Okay. So with that said then, angle QMO is going to be 180 minus 67 minus 94. And that's going to be 19 degrees, I believe. Let's see if I did good. Yeah. So there we go. Okay, so a few different things. We're using parallel line theorem, the alternate interior angles. We're using the fact that angles add up to 180 in a triangle. And we're using angles add up to 180 or a supplementary across a straight line in order to find each of those angles in that diagram. Now, if QP is parallel to MR, find these other angles. Okay, find these other angles. We're not going to bother with doing that, I don't think. I think we're good. So, here are some key ideas. You can prove properties of angles and triangles using other properties that have already been shown. We know that the angles in a triangle add up to 180, and we know that an exterior angle is equal to the sum of the two non-adjacent interior angles. Okay? Alright. So, for homework, you're going to be working out of section 2.3 in your textbook. Just try and do as many questions as you can on this. No quiz, no homework check, no pressure, but just get some practice with this so you understand the process of how to find these missing angles and stuff, okay? Alright.